So welcome everyone. Welcome to Strait Science. Strait Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus in Nome and University of Alaska Fairbanks Alaska Sea Grant, also in Nome. And tonight you're in the home office. And both Alaska Sea Grant and Northwest Campus, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. So tonight, Jessica Crance, we have Jessica Crance. She is no stranger to strait science. She gave us a talk about right whales, including right whales in the region. I had to look it up, March 2022. And if you go back to the YouTube channel, you can find Jessica's last presentation was less than a year ago, May of 2024, where she outlined this particular survey of 2025 that she was on. She gave us, or 2024, she gave us what was going to be on the survey, why they were doing it, where they were going, and here she is, just as promised, with the results. So we're very excited to have her give us those results of the International Whaling Commission funded, that's the IWC, funded cruises for large whale populations, looking at the status. But she can do a better job talking about it than I can. But who is Jessica Crance? Jessica Crance is a research biologist with the Marine Mammal Laboratory at the NOAA Alaska Fisheries Science Center, which is located in Seattle. So she is coming to us even later in the day than we are at. And so we're thankful for you with the time zone change there to accommodate that, to get news to us, and we very much appreciate that. With that, we're glad to have you back, Jessica. Take it away, and we're so glad you're here. Thank you.
Fantastic. Thanks so much, Gay. Yeah, it's a real pleasure to be able to talk to you all tonight about the results from some of the marine mammal surveys that I've been lucky enough to be a part of for the past several years. As she mentioned, they are sponsored by the International Whaling Commission. But before I get into those, my talk actually begins about 45 years ago. So in 1978, the International Whaling Commission implemented the Southern Ocean Whale and Ecosystem Research Program, or the SOWR program. And the goal of this program was to systematically survey the Southern Ocean around Antarctica to try and obtain abundance, density, and stock structure information of large whales, which at the time was largely unknown. So over 32 years of surveying, they covered over 216,000 miles. They circumnavigated Antarctica 3 full times. And this led to over 43,000 sightings of cetaceans and a wealth of information on large whales in the Southern Ocean. So because of the success of this SOWR program, the IWC then switched its focus to the North Pacific. And thus the Pacific Ocean Whale and Ecosystem Research, or POWER program, began. So like SOWR, the goal was to systematically survey different portions of the North Pacific and to, again, obtain information on abundance, density, and stock structure of large whales. And these POWER surveys are approximately 2, sometimes 2.5 months in duration. And the ship time and the crew are provided by the government of Japan. And so it's a really remarkable opportunity to participate in these large-scale, internationally collaborative marine mammal surveys for really minimal cost to us. So these 2 plots show all of these survey areas of the POWER surveys to date. So in the earlier years, they really kind of focused on kind of the central North Pacific, and then they've started kind of branching out or resurveying areas since then. And it's just been a monumental effort to survey this massive portion of the North Pacific. So for the purposes of this talk, I'm just going to be focusing on those surveys that were in the Bering Sea. So just briefly talking about the methods on these power surveys, it is a visual line transect survey for marine mammals. And although large whales are the focus, we do identify and count all species that we encounter. The observers use reticle binoculars, and then they scan ahead of the vessel and out to the beam. And the primary observing platform is the crow's nest up at the top of the mast, where we've got two observers. And then the data are recorded from the flying bridge, which is that lower circle that's outlined there. And so the scientists that are on the flying bridge will also scan for whales, but they only call out sightings that are missed by the crow's nest. And then there's also a secondary platform outlined in green there. It's called the IO platform, and that's used about 50% of the time. And this is to obtain independent sightings from a separate platform from the primary one. And these are used to get what's called G0, which is an estimate of the number of sightings that is missed by a single platform. So when you combine those data, it gives you a more accurate number as far as the abundance of animals, because it lets you account for any sightings that are missed from a single platform. And if we encounter high priority species, we will attempt to get photo ID photographs. And then we could also attempt to get biopsy samples, which is a small piece of skin and blubber. We use what's called a Larsen gun that allows us to kind of get longer distance shots from whales. And from these biopsy samples, we can get a wealth of information about the animals. We can get sex, genetics, reproductive status, health, all kinds of information. So they're really valuable pieces of data that we can collect when we're out here. And so after surveying in that central North Pacific region for 7 years, the IWC then decided to survey the Bering Sea for the first time in 2017. And because we would be surveying that southeastern Bering Sea portion that goes right through right whale critical habitat, which is that red polygon area that you see, we decided to include passive acoustics for the first time in Power to help us locate North Pacific right whales. And so I joined Power for the first time as the acoustician in 2017, and I've been a part of these surveys ever since. And so when I'm out there, I use an instrument called the sonobuoy, which is a free-floating instrument that's deployed over the side of the vessel. The sonobuoys will transmit audio signals in real time using VHF radio waves back to a receiver on the vessel. So if a whale starts calling, I'll hear it as it happens. And the other really great thing is that sonobuoys have directional capabilities. So if we start hearing a right whale, we can deploy multiple sonobuoys at once. We can monitor as many as 3 at one time simultaneously. And then we can actually localize or triangulate on their position. And then from there, our plotting software will give us a position, distance, and bearing to the animal, which we can then give to the captain, and the boat will head that way, where we hopefully will find the animals and then can start getting those photo ID photographs and biopsy samples. And these have been really instrumental in helping us locate right whales over the past several years. So why the focus on right whales, right? Gay mentioned I already gave a talk a couple of years ago about them. So right whales were once widely distributed throughout the entire North Pacific and Bering Sea before they became the target of commercial whaling. And it's estimated that roughly between 26 and 37,000 animals were taken, with the majority of that occurring within just a couple of decades. And so we think this brought the eastern population down to what were likely the high hundreds. And then the Soviets began illegally whaling in the early 1960s. And in just a handful of years, they took over 700 additional animals and just decimated what was left of the eastern population. So to try and get an abundance estimate to see how many of these right whales remain, NOAA began conducting surveys in the Bering Sea. And from those data, they found that the population size was only roughly 30 animals. Of that, there were only 8 estimated females with a 3-to-1 male biased ratio, which unfortunately is the opposite ratio you want when you're trying to rebuild a population. And although these results are specific to the Bering Sea, the infrequent sightings outside of that area suggest that the overall population size is likely fewer than 50 animals. So this population is very much facing extinction, potentially within our lifetime. So, because of that, NOAA designated 2 areas of critical habitat, and these are shown in those red dashed polygons that you see. There's a large area in the southeastern Bering, and then a smaller area off Kodiak Island in the Gulf of Alaska. And so we know that these animals can be found in these areas in the summer on their feeding grounds every year, but we have no idea where they go, when, or even if they leave the Bering Sea. Their migration routes and their calving grounds are completely unknown. And so there are so many questions, even just basic life history questions about this population that we don't know. So any opportunity to study these animals, to conduct surveys for them, and we're going to jump at the opportunity. So these power surveys then presented a really fantastic opportunity to survey not only for right whales, but all large whale species. And so this plot here shows the track lines taken by these power surveys during the 3 years that we were in the Bering Sea. So you have 2017 in orange in the Eastern Bering, 2018 is in purple in the Central Bering, and then 2024, just last year, is in teal. And last year, we also went north of the Strait and did a small survey portion in the Southern Chukchi. And so I want to just go through some of the results from these surveys and then also look at 2017 versus 2024, since we were surveying in the same area in both of those years. You're going to see a series of maps like these, and so I want to kind of explain them briefly. On the left, you have the visual sighting results. And the track lines are color-coded just like what you saw. And then the circles represent the individual sightings of each species. So it's green for 2017, red for 2018, and blue for 2024. And then on the right-hand side for that plot, that shows all of the acoustic results. So the gray dots are all of the sonobuoy deployments, and then the colored circles are detections of that species, meaning that sonobuoy had calls from that particular species, and they're colored with the same color coding as the visual sightings. And so these 2 plots are for the fin whales. And so from looking at this, you can see that they were pretty ubiquitous throughout the entire southern Bering Sea shelf and into the deep basin. And then in 2024, when we went up into the southern Chukchi, they were pretty prevalent up there as well. And if you look at these, there's pretty good agreement between the visual and the acoustic results. It may look like we had more acoustic detections than we did visual sightings. But keep in mind here that fin whale calls are very loud and very low frequency, and they can be heard from pretty far away. And so it's possible that multiple buoys that you're seeing on this map could potentially be picking up the same calling individual. So that's why it looks like there may be more animals detected on buoys than visually sighted. But generally, good agreement between the two. So here we have the results for humpback whales, and they were kind of clustered really into 3 main regions. We had the southeastern Bering Sea, we had a cluster in the deep basin, and then again, a small cluster up in the southern Chukchi. And again, there's pretty good agreement here between the visual sightings and the acoustic detections. These 2 plots here show our gray whale results. And so grays were really only sighted in the northern Bering and the southern Chukchi Seas, clustered in both the Hope Basin and the Chirikov Basin. And with gray whales, you can see pretty clearly there were quite a few more visual sightings than there are acoustic detections. Gray whales tend to be pretty quiet when they're up here on their feeding grounds. And so they tend to make for better visual survey candidates up here than they do acoustic monitoring candidates. So for killer whales, a pretty noticeable difference here between the visual and acoustic results. Visual sightings were mainly clustered in the southern Bering. And while the same is true for the acoustic detections, there were quite a few more acoustic detections than there were visual sightings. And this mainly is just a result of the extremely vocal nature of killer whales, particularly when they're in groups. If they're residents, they're really quite chatty. So they're excellent passive acoustic monitoring candidates. So another species where the visual and acoustic results were very different are sperm whales. And so while both acoustic and visual detections were all in the deeper waters, there were quite a bit more acoustic detections than visual sightings. And this is very much a result of sperm whale dive behavior. They have very long dive times where they are typically clicking almost constantly. They're very much like a metronome acoustically. And so, because of their long time spent underwater where they are echolocating, they tend to make much better passive acoustic candidates than they do visual ones. So on this slide, we've got two species. On the left are minke whales. There were a few sparse visual sightings throughout kind of the entire survey area, but there wasn't a single acoustic detection in any years. So minke whales up here tend to be pretty quiet up on their feeding grounds. In all of my power surveys, not just in the Bering Sea, I've never had a minke whale detection. So they are definitely better visual survey candidates. And then on the right, we have bowhead whales. And here on this plot, I have combined the visual and acoustic detections onto one, as there was only one sighting of two individuals that occurred on our 2024 survey, and they were only detected on the one sonobuoy that was deployed near that sighting location. And this was a surprising sighting for us to have. It was a bit early in the year for bowheads to be down near Point Hope. This sighting occurred on the 17th of August. And if I recall, it was our first official on effort sighting of the survey. So it was a pretty fantastic way to start the survey, if a bit unexpected. And then here we've got the results for North Pacific right whales. So we did have quite a few sightings in 2017, primarily in the southeastern Bering, although we did have those two sightings in 2018, including one that was just south of St. Lawrence Island, which was a really fantastic sighting. And that animal stuck around in the northern Bering for 3 weeks. It was later resighted up near Chukotka in August of that same year. So that was a really, really fantastic sighting. But despite our best efforts, there were zero sightings of right whales in 2024, even though our track lines went right through the right whale critical habitat. But this is another one of those species where you often get more acoustic detections than you do visual sightings. Um, they are not only extremely rare, and they do tend to be fairly vocal in bouts, but for some reason, these guys have an uncanny ability to always be hiding in really crummy weather. So even though in 2024 we heard them on a couple of occasions, we just couldn't make that magic happen, and we never got that sighting. Um, but I will say, despite the lack of sightings this year, or not this year, 2024, last year, can't believe it's already April of 25. But these power surveys have really been instrumental in helping us find and study North Pacific right whales. And thanks to these power surveys, since 2017, we have photographed 17 individuals. We've gotten biopsies from 6 animals. We've added 9 new animals to the catalog. And this is just from the power surveys. This doesn't include other surveys or opportunistic reports. And so it's really been incredible results that have added tremendously to our knowledge of North Pacific right whales. So it's really been an incredible opportunity. And I'm hoping that we can kind of continue that success with right whales in our future surveys. Okay, so now I want to talk a little bit more in detail about the years where we surveyed the same area, the Eastern Bering Sea. And I want to look at 2017 results in more detail compared with those from 2024. Okay, so now on the left side, those two plots are the sighting data from 2017 for fin whales in red and humpback whales in blue. And then on the right side, those two plots are the 2024 sighting data, again with fin whales in red and humpbacks in blue. And so there's generally similar coverage in the area, but our track lines are fairly different. But what I want to really kind of focus on is the Southeastern Bering. And so in 2017, we had quite a few fin whales and humpback whales in the Southeastern Bering, even all the way into Bristol Bay. But when you look at 2024, we had exactly one fin whale and one humpback whale over 350 miles of track lines. So pretty noticeable difference between the 2 years. And then this plot here shows North Pacific right whales, where we had in 2017 not only quite a few sightings, but a lot of acoustic detections as well. And the acoustic detections here are in the purple triangles. And here I've got that right whale critical habitat on the map for your reference to help spatially orient you. And now you can highlight these results with the whopping 3 acoustic detections that we had in 2024 with 0 sightings of right whales. And so even though a direct comparison is pretty difficult because of the different track lines, the coarse resolution of the track lines, there was a noticeable lack of large whales in that Southeastern Bering in 2024. Okay, so where were the whales, right? What was going on? Well, to try and figure that out, we kind of need to take a step back and look at it from the perspective of the entire ecosystem, which, as I'm sure most of you know, in the Bering Sea is entirely driven by sea ice. So in the Bering Sea, everything here depends on what is called the cold pool. And this is a very kind of rough, crude schematic that I put together to kind of help illustrate this. So in very strong, heavy sea ice years, you end up with a pool of extremely cold water on the bottom that persists well into summer. And with this comes those really cold bottom temperatures, and they favor large lipid-rich copepods and large zooplankton that tend to be concentrated in that area of that cold pool. However, in a lower sea ice year, there is either a very weak or no cold pool established. And so, with that, this leads to warmer bottom temperatures that, combined with earlier spring blooms, results in fewer smaller copepods and krill in the fall. And there aren't really enough of them in large concentrations to support a large number of whales. And so, right, because the whales are going to go where the food is more dense and more concentrated. And obviously the ecosystem, it's much more nuanced than what these two schematics show, right? There's a lot more happening than what is shown here. But this gives you the general idea, right? Strong cold pools means heavy concentrations of prey well into the fall. Weak or no cold pool means very limited prey in the fall. Okay, so let's then see what was happening in the Southeastern Bering Sea during those 2 years. So this plot shows the bottom temperatures for 2017. And that red polygon again is the right whale critical habitat for your reference to help orient. And in 2017, we had a pretty decent cold pool that extended all the way down into that right whale critical habitat. However, when you now look at the 2024 bottom temperatures, you can see that that cold pool stopped much farther north and was pretty much non-existent south of the Pribilofs, right? There was essentially a 3-degree difference in bottom temperatures within that habitat between the 2 years. So what does that mean for their prey, right? So these data were collected in kind of the late summer, early fall during roughly the same time period as our marine mammal surveys. And so these 2017 zooplankton data were collected along the 70-meter isobath, and that tends to run right down the middle of those cold pools. So on the top, you've got the large copepods, calinus copepods, that are the main prey of right whales. And on the bottom, you've got euphausids or krill, which is a main prey for, your fin whales, your humpback whales. And so you can see, pretty decent numbers, pretty good concentrations down there in the habitat. And now here are the data from a 2024 survey. Different spatial scales between them. But the one thing I want to point out is the wildly different scales for the large copepods. It's a difference of a factor of 10, right? But even different scales aside, there were essentially 0 large copepods or even euphausids down in the southeastern Bering Sea in the late summer, fall of 2024. And this was only, 1 or maybe 2 weeks difference from when we were there. And so here I'm kind of compiling it all together for you to see. And please note these data are still very preliminary. We're still looking into other explanations for the differences. But this kind of helps maybe explain what was going on. So on the left now are the 2017 sightings data. I've shaded the whole thing in blue to kind of represent a cold year. And all 3 species are all on one plot now. And now let's add, here we have the bottom temperature, and then we'll take it a step further and we'll overlay those zooplankton data on top of that. And so you can really see how that cold pool comes quite a ways down into the southeastern Bering, bringing all of those large numbers of copepods and the euphausids all the way down into there. And now if we do the same for the 2024 data, here it's all shaded in red to kind of signify a warmer year. Here are all those viz data again. And on the right, here's our cold pool data. And you can see again where those data essentially stopped. And apologies for the kind of different projections. I was working with just plots and not the raw data. But if we superimpose the zooplankton data, you can very clearly see the lack of prey that are occurring in that southeastern Bering. And how it's essentially all farther north, up near those colder temperatures. And unfortunately, we don't have those bottom temperature data farther to the west to kind of see how that correlates to sightings that may be occurring just outside that habitat. But I think it's pretty interesting here that we can see these really stark differences between the oceanographic and the zooplankton data, and kind of how that translated into what we were seeing at that time when we were out there in terms of the large whale data. And this fits well, jumping the gun. And all of this fits really well with work that's done by a colleague of ours here at the Alaska Fisheries Science Center, Dr. Dave Kimmel. In a recent paper that he published, he compared sea ice and cold pool extent to the zooplankton communities within the southeastern Bering Sea within 3 shelf domains. And so you can see on this map here, we've got 3 different kind of domains outlined. You've got this coastal domain that is from the coast out to the 50-meter isobath, middle domain, which is essentially from 50 to 100 meters. And then you have the outer domain, which is from roughly 100 to 200 meters. And that cold pool, it tends to be concentrated within that middle domain, within that kind of 50 to 100 meter isobath. And so here on the top, we've got these plots showing the average sea ice extent on the left and the cold pool extent on the right. And these are broken down by kind of cold versus warm regimes, right? When was it kind of warmer years versus colder years? And so you can pretty clearly see here that during these colder years, there's quite a bit more sea ice and correspondingly a much larger cold pool compared to those warmer years, which you would expect. Then when you look at the zooplankton data here, these two bottom plots show the abundance for calanus copepods, which are those large copepods. They're the primary prey of right whales. For that middle shelf domain on the left and the inner or coastal shelf domain on the right. And here you can see pretty clearly that during those cold years, there's a much greater abundance of calanus copepods in the southeastern Bering Sea, particularly in that middle shelf, which is right smack dab in the middle of that right whale critical habitat. So it's pretty interesting to see how everything's kind of tying together in terms of oceanography, zooplankton, large whales. And so I kind of want to start wrapping things up a little bit by chatting about our upcoming 2025 Powers Survey. So this year, we're going to be surveying the southern Chukchi and the central Bering Seas. And so we'll be leaving from Dutch Harbor on the 4th of August. We'll be heading north, basically booking it straight on up to the southern Chukchi. We don't have any preset track lines for this portion. For this, our main priority is biopsying gray whales, with the focus of trying to determine stock structure. So we're basically going to be focusing our efforts in that darker blue square up there where there's the highest concentration of gray whales. We'll spend about 8 days there, and then we'll head south to start our track lines in the central Bering. We're going to work our way kind of north to south. We'll finish around the 20th of September before heading back to Dutch Harbor. But the really great part is we surveyed this same area in 2018. So we'll be able to compare this year's surveys with the 2018 results in a really similar comparison to what we did here. And I think it's going to be really fascinating to see the differences between the two, much like we saw between 2017 and 24. And so, again, the objectives of the power surveys are always to get that abundance and density information for large whales. But we do have kind of other objectives while we're out there. Our priority while we're in the southern Chukchi is, again, to biopsy gray whales and obtain as many samples as we can to help better understand stock structure of the animals in that region. And then when we get to the southern Bering Sea, humpback whales are a high priority species to help understand stock structure, particularly around the Aleutian Islands. And then, of course, North Pacific right whales are always our highest priority whenever we are lucky enough to find them. And any information we can get about them will help with population information, whether it's just photo ID photographs or biopsy samples, or even just seeing them. They're always our top priority. So the methods will be the same as in previous years. It is primarily the visual line transect survey, where all marine mammals will be identified and counted. But for higher priority species, we'll also obtain those photo ID photographs and those biopsy samples. And we will again have the passive acoustics on board to monitor for vocalizing marine mammals and hopefully help guide us towards right whales. And I also want to mention the communication plan during the survey. So I will again be the NOAA representative on board. I will be sending daily emails to villages and other interested parties during the survey. These emails will include our current position, course and speed, planned activities for that day, our current weather conditions, and then any species that we've seen while we're out there. And then if for whatever reason you need to get in touch with the vessel, you can either email me, my email address is down there at the bottom, or you can hail the vessel over VHF radio. The ship's name is the Yushin Maru 2. You can ask for NOAA or Crance, and then I'll come on up to the bridge and talk with you over the radio. So really looking forward to being out there again this year. I just want to quickly point out some of our data sources that we're using in this talk. Again, this is all kind of preliminary data. We're still working through everything to figure out exactly what's going on, but this kind of gives us a pretty good idea. Special thanks to Dave Kimmel, Phyllis Stabino, and Sean Bell for providing me with oceanographic and zooplankton data. And with that, thank you so much for letting me chat with you guys, and I am very happy to take any questions that you may have. Thank you so
All
much.
right. Well, thank you very much, Jessica. That was great. I learned a lot, and I didn't even know we were going to get the 2025 bonus update. So that was good too.
Yeah.
And this is the time for straight science speakers. I know we already have someone with a question. And while you're thinking of your questions, this is the time the audience can show a little love to Jessica in the chat box. Or some people are so savvy they can make things happen on the screen. I don't know how that works, um, but know that it's never easy being a public speaker, and we're so appreciative Jessica is coming to us from a different time zone, no less, and she's already probably had a long day, and she's having it a little longer with us, and so we appreciate you taking the time to let us have the opportunity to learn more about what happened last summer and about what is coming potentially this summer with cruises, and very interesting results. I know I've got some questions, but you did have a question right off the bat, and that was
Mhm.
Adam Militello. If you still have your question, you go straight to the front of the line.
Yeah, thank you, Gay. Jess, that was a really good presentation. I found it pretty insightful for what my research is at UAF. I had one question about the sampling of the biopsies. Because you showed in the graphs there was a lot of the audio versus visual detection on the mappings, and but you also mentioned that you did like the biopsy testing. Was that for all of the species you mentioned, or were there only specific ones that you could get the samples from?
So we biopsied the higher priority species. So we were able to obtain biopsy samples from fin, humpback, gray whale, right whale when we found them. Um, those were the highest priority. We may have gotten one from kind of killer whales if they were in an unusual area, but those are the four primary species. Yeah.
Thank you.
Yeah, and I'll mention too, they're still currently being analyzed. The right whale samples we did kind of rush in terms of prioritizing data analysis. From the 6 biopsy samples that we got from the right whales, 5 of them ended up being males, and there was 1 female.
Do you know which stock for those right whales?
Yes, they were all from the eastern stock, including the animal that was just south of St. Lawrence.
So, and you might want to, I don't know, you could probably explain better what the difference is between the stocks. What does that mean,
Yeah,
eastern stock, for the audience?
absolutely. Yeah, I didn't want to go too much into right whales, but I can talk about them all night long. So the North Pacific right whale is split up into 2 different populations. The eastern population is the one that's in kind of Alaska and Canadian US waters. The western population is found in kind of Russian, Asian, Japanese waters. They are genetically distinct. So even if there's overlap between their feeding grounds, they are not interbreeding. And so all of the biopsy samples that we collected that were in Alaskan waters were from the eastern population.
Awesome. Thank you so much.
Yeah, thank you.
And we have a question from Sue Moore. Go ahead, Sue, and welcome.
Yeah, thank you, Gail. And Jess, thank you so much for your presentation. Really great. I'm really happy to see all these results that you have. I actually have 2 questions. One is about the photo ID. You mentioned 9 new right whales in the catalog from the Sour Power Cruises. And
Yeah.
so my first question is, does that have an impact? Does that change the idea that there might be more than 50 whales in that population? But my second one is really more comprehensive in terms of what I've been doing with the DBO cruises and doing sighting surveys while we're doing the distributed biological observant cruises. And when I was looking at your 2017 and 2024 track lines, it seems to me that by combining that perhaps with some of the DBO data and the oceanographic data, especially since Phyllis and Sean are involved in some of that as well, we could do a similar sort of analysis as you showed for the southeastern Bering. So those are 2 different questions. I guess I just piled them on. The first one is very straightforward about right whales. Do the additional photo IDs change at this time anyway, the estimate of population size, which is critically low. And the
Yeah.
other one's more broad in terms of we're seeing humpbacks, minkies, fin whales, as you pointed out, in the southern Chukchi Sea. And I think if we could combine these data sets, that would be good. My question really is the IWC data set available for that?
Yeah, thanks, Sue. Good to see you. Glad you're able to make it. So, to your first question, the easier one, yes, absolutely. We have had enough kind of big right whale sighting years where we are now in the process of using those photo ID data in a mark recapture style analysis to try and get at new abundance estimates. Paul Wade has taken the lead on that. He does have some rough numbers. He's had to prioritize a couple other things. And so the official manuscript will probably be coming out hopefully later this year. But yes, we should hope to get a new abundance estimate. We're also hoping that we might be able to include sightings from the Gulf of Alaska or other regions to potentially get a combined number. So it won't just be Bering Sea focused, but Bering Sea plus elsewhere. So stay tuned for those results. Hopefully they're coming soon. To your second question, absolutely, I would love to do that. We've already been talking about kind of turning these results into a short manuscript. I think if at this point, if we wait until 25, when we've got 2 years for both regions, we can combine that. And if we can include the DBO and extend it even farther north, I think that'd be a really fantastic paper where we can combine everything and really get at some of those kind of ecosystem based nuances to what's happening in some of these explanations. And yeah, I think we'll probably be reaching out after this survey to try and start combining those. So for the IWC data set, to formally use the sightings data, you would technically have to go and submit a formal proposal for their data. Since you have someone on the inside, I could probably expedite a lot of that and make it a little bit easier and say, hey, we want to do this and combine all of that. And I would love to. I think that'd make for a really fantastic manuscript.
Yeah, that'd be great. I'd really like to focus on the southern Chukchi because that's the hematocrit thing right now that's changing so quickly and with multiple species. And I think we have the oceanography to go with that. So that would be great. Yeah.
Yeah,
Thank you.
absolutely. Yeah.
Thanks.
So with
Yeah,
that,
thanks, Sue.
thank you very much, Sue. Can somebody describe what the DBO, the Distributed Biological Oceanography,
Yeah.
what that means? I know some people will not understand what that is, and it would be super helpful. Thank you.
Yeah. Sorry, Gay. Yeah,
That's
you're
okay.
right. You're right, exactly. So the Distributed Biological Observatory, which is a mouthful for sure. It's an oceanographic program where we go to hotspots. That means where there's a lot of biological activity. And there are 5 primary places where we go. I think Lee Cooper might still be on, and he can correct anything I say wrong. But basically, from just southwest of St. Lawrence Island, there's the first DBO area, then the Chiricahua Basin, north of St. Lawrence Island. Then the third area is in the southern Chukchi Sea, where I was just talking with Jessica about. And that basically is Point Hope, and then south from there. And then Jackie and Lee have a line from their earlier surveys. So that area north of Bering Strait to Point Hope has had a lot of surveys done because it's a big hot spot and getting hotter biologically. It's changing very quickly. There's 2 other areas in the northeast Chukchi. One is just, let's see, a little bit north and west of Wainwright. The other is across Barrow Canyon from Utqiagvik. So those 5 areas, and I'm sorry I don't have a map, but
That's okay.
those have been sampled routinely and in a standardized way so we can compare across years since 2010. And Jackie and Lee were out there on other programs before then. I joined the program in 2010 and have done visual surveys for all marine mammals on the surveys I've been on. Thank you, Lee. I think that's you. That's the map. Those are the areas that I just tried to describe. So that's the DBO. And sorry to just jump in on that, but
No,
I'm
that's okay.
very keen on that DBO3 area.
Tell me if I'm wrong, but the DBO is a series of stations for ships that are doing research to stop and do grabs. Is that correct? So that
It
every
is
year more and
international,
more
yes,
vessels.
Jay, you're right. But
Or-
the foundation of it really has been Jackie and Lee's program
Sure.
that started with the Laurier, but other ships do these stations as well. It is international.
Yep, and it's a way that way, I think it's a kind of a cost sharing and a way to get more data if everybody's stopping and getting a little look at one place in one point in time, regardless of all the other things you're doing with ships. It's so thank you very much, Sue, for that. Appreciate the didn't mean to get you, but
No.
appreciate that.
I'm sorry to take so much time.
No, it's all right. We are not rushed at Strait Science. We want everyone to get their chance. This is the
Very
Bering
good.
Strait region, and if you have something to say, we'll absolutely want to hear it. So with that, any other questions in the chat? We'll just think Sue's got her hand up. That's okay, Sue. If you go to react or something, it should say lower hand or something like that. I don't know. I see Lee Cooper and Jackie Grebmeyer on. Do you guys have a question for Jessica? Nothing. Okay.
Yeah,
Well,
no specific question, but I like the exchange about sharing data, and let's do whatever we need to do to get the IWC data and share it with the observations we've already made. You know, that the line near Point Hope looked very similar to where we sample anyway. So yeah, they're truly
Yeah.
a lot of whales up there. Yeah.
Yeah. And the other thing
Yeah,
I would say,
absolutely.
working with the Catherine Burchak and others that are, with the monitoring, acoustic monitoring, we had a nice discussion of passive acoustic monitoring plans at the Arctic Science Summit Week that we had in Boulder. Discussions with a lot of local, international, and indigenous communities were at that meeting. Over 1,000 people were at the meeting, and it was very much
wow.
having a symposium with coastal communities too. So the whole idea, so this combination of marine mammals and the importance to the communities was brought up quite strongly there too.
Oh, fantastic. Glad to hear that.
Okay.
Yeah, no, we're very much looking forward to doing a much more thorough and detailed analysis to incorporate all these multivariate data sets than just my, hey, I'm going to stick the zooplankton on the cold pool plot and here you go. Obviously, this is all, again, very, very preliminary, but I think it really tells a pretty compelling story. And so we're looking forward to really doing these analyses justice and turning this into manuscripts. Yeah.
awesome. So I have a question. I don't see anyone else, so I'm going to jump in while anyone else is formulating their questions. I have a couple actually. And so I just want to make sure I understand that, we had what some would consider a cool summer last year. It was very stormy, as you probably experienced at sea. I have thoughts on what that actually was doing, was actually warming up that cold pool faster, because we were really just wind blown a lot of the summer, a lot of freshwater runoff, a lot of storms, and we were always at flood stage here. So in our rivers, so we were, I don't know about flood, but we were at high water, knocking out weirs. I mean, it was just a tremendously difficult summer for lots of things due to the weather. And so what I heard was, and stop me if I'm wrong, is that, it's pretty dramatic. 2017, you saw whales down in the southern Bering Sea and Bering Strait region. But in 2024, those whales were up north. Almost everything. I was writing down, like gray whales, humpbacks, fin whales even, right? Everybody's moving up north in 2024, which was colder. But you were also saying that there was very little lipid rich or oily fatty zooplankton to the south, and that was based on temperature. Is that my understanding? Did I get that right?
Yeah, that's
Okay.
that's correct. That's our current guess right now.
Okay.
So in 2024, it wasn't a warm year in terms of being comparable to what you see in the warmer regimes, right? It wasn't on par with our warmest years. And everything in the spring kind of set up as if it would be a decent cold pool year. But then something shifted, according to the oceanographers, outside my wheelhouse, but according to them, something shifted for whatever reason, and you didn't see that cold pool extent that they were expecting based on kind of the conditions in the spring. And so, you know, if you look at the temperature data all the way down in that southeastern Bering, the kind of residual heat data are showing that it was, you know, a couple degrees warmer than the average. So it was a warmer year, but it wasn't a hot year by comparison. But it was enough to where we just weren't seeing those large, fatty, kind of good zooplankton prey down in that southeastern Bering. So they were either farther north or potentially to the west. And that is kind of one of the downfalls of the power survey data, is that those track lines are pretty coarse, right? We're trying to cover a massive area by a few track lines. And so we're certainly only kind of seeing a very small snapshot of it. So it's entirely possible that our track lines just weren't positioned perfectly over where the whales were concentrated.
You just found a patch of nothing versus a patch of something potentially.
Right.
Yeah.
Right. Exactly.
So my questions are from that, and thank you for all that, because that's a good explanation. So the other question was, you know, people are asking IWC data and all this. Are you actually getting, there's so many other cruises, and I don't know if they have dedicated marine mammal viewers that are or whatever, but are you able to, if you're looking for like a large data set, like whatever the IWC International Whaling Commission has, are you also within NOAA and all the different cruises that go on, if they have a marine mammal sampler, or even if they're an industry vessel that has a marine mammal observer, even Coast Guard, marine mammal, whatever is available, do you guys pull that in as well when you're talking about these, not the acoustic, of course, but like visual sightings? Would that be something that you would pull in other research efforts if they have the correct, you know, person on board, if they're trying to do marine mammal surveys and all that? Are you pulling in as well? That's the question.
Yeah, it depends on kind of what the overall goals are, because if
Yeah.
you want to get specific abundance or density estimates, you have to kind of follow that very strict protocol of the line transects. And so if it's more of an opportunistic observer that's on board, we could use those data, you know, in kind of a similar fashion to what I've done here, but we wouldn't be able to use those data to get abundance estimates or density estimates.
Right. But
so depending on what the goal is.
Yeah, if your acoustic is getting from miles away, maybe there's a ship actually within your acoustic range that maybe they actually write something down. That I don't know. I just wanted to make sure you're using what you can if that's something. But my other question, come on, I'm the only one going here. But my other question is, so this is an International Whaling Commission funded cruise. Awesome. So that is, for people who don't maybe not understand, that's kind of the United Nations for whale issues, right? All countries are in, most countries, and maybe some that aren't really directly involved, but there's an awful lot of international collaboration and representation at the International Whaling Commission level. You know, it always strikes me, right? We're always on, it's an American ship. You can't cross over, especially nowadays. It's very difficult to get any kind of research permit to work in Russia, much less talk with people and share data at that federal level. But this data seems to show to me, like I look at it as a resident and I'm thinking, well, we've got right whale up there off St. Lawrence Island. We've got humpback now just on the southern Chukchi and beyond. And so it's likely that these whales are utilizing both sides of the Bering Strait, where you start to come way down, you know, we're just plumb run out of water in the Bering Strait region. So is there like what is when we look at what we're dealing with now, we're talking about ice is weak right now. Ice will be probably, that'll probably be a common problem moving forward, as it is now that we live every year, it's a problem. And we are seeing the rise of, for us, industrial maritime traffic. So there's like research vessels and commercial fishing vessels. The Russian side's got trawlers, commercial trawlers going north. Through the Bering Strait in the summertime, we see the LNG tankers. We see all kinds of industrial cruise ships now. We have cruise ships coming through. Seeing this shift of whales, the large cetaceans, not just bowhead, but the other species going into the sort of the narrows between the Bering and the Chukchi Sea. Is there plans to sort of use this data to, well, I guess, what are next steps for concern regarding, ship strikes or marine debris or accidental discharge? Is there a component of your research that's going to be addressing some of that in the narrows of the Bering Strait for these large whales? I don't know if that's yeah, go ahead.
From the IWC standpoint, I'm honestly, I'm not sure. I'm not an official like committee member of the IWC. Right. From a Marine Mammal Lab acquisition standpoint, we are obviously always collecting data on the vessel presence as well as the marine mammal acoustics, and so that's always something that we're looking to investigate is, how vessel presence is changing, increasing, shifting, how that could potentially be impacting marine mammals. So specifically from an IWC standpoint, I am not the person to speak to that. I'm happy to point you into the direction of who you can talk to.
Yeah.
But from our standpoint at the Marine Mammal Lab, that it's always something that we're interested in. Absolutely.
Yeah. Well, thank you, and yeah, let me know who is the contact to sort of bring that up, because that was sort of a very interesting. We do notice more humpback whale activity in the region as it goes north, more stellar sea lion movement. The whole ecosystem is shifting, and we're seeing that. Mm-hmm. And so it does make you wonder who is now in a place when we get in that confined area, southern Chukchi, northern Bering Strait. At the same time, we're increasing other things. It's sort of like a perfect storm for us. And we're just very, very good to know you're not the right person to bring this to.
No, I'm not.
It does make me think how that information can be used, or maybe is being thought about on an international level with our Russian Federation, Chukotkin neighbors, sharing this, not only the opportunities, but some of the concerns that are pretty serious for the marine ecosystem and safety at sea and things like that. So we really appreciate, and food security for both sides of the Bering Strait region.
Yep.
So thank you for that.
Yeah.
Last question. So do minke whales sing?
Sing? Oh,
you never detected them. Is that normal to not hear them at all?
They're pretty quiet up on their feeding grounds. There are areas where on our long-term recorders we do get fairly consistent minke whale detections. There's I believe it's our Cape Lisburn mooring that had quite a few of them. They're minke boings. But for where our track lines are and for where we've been seeing them, I haven't heard a single one. Those guys are quiet. Frustratingly
maybe those
quiet.
killer whales keep everyone on the low because they're a smaller whale, the minke, and maybe if you chatter too much.
Gray whales are the same, man. I have very few gray whale detections in our power database. Yep.
Okay.
Yeah.
All right. With that, no other questions? Nothing in the chat? We thank everyone for coming. We thank you, Jessica, for a very nice presentation. If you'll just hold on for 2 seconds.
Absolutely.
And Sue, if you want to join in, that would be good. And next week, Strait Science will be very close to home here. We will have the City of Nome Port Project Director, Joy Baker, will be giving Strait Science on April 10th. And she will be giving an update on the situation with the Port of Nome modifications. So we'll get to hear the latest and how that port, it's been off again, on again, off again. We'll hear the latest round of information from the city of Nome. So we look forward to hearing that and seeing what lies ahead for us in that department. So thank you all again, and we'll see you next week. Have a good night, everybody.